Hello everyone. Today we will be learning about SPDT Relay. SPDT stands for Single Pole Double Terminal Relay. Okay. A relay, any relay, is a device which switches between two different output circuits controlled by a single input signal. So we give it one input signal and it switches between two different output circuits. For example, do you know how uh, an inverter switches between the mains and the inverter itself? For example, when the main electricity is on, your house is given electricity from the mains, and the moment the mains electricity goes off, you don't have to go and change any switch. So how is that done? How is that switching happening? It is using a relay. Okay. Let us take another example. We have generators which automatically switch on. So how are things happening? The input is actually coming from the mains, and when the mains electricity goes off, the relay switches back from the mains to the generator. So generator gets switched on, and the electricity now is coming from the generator. So this is an automatically kind of switching which is happening, right? And that switching is happening depending on some electricity which is given to the relay. So basically it is a switch, but it is not a manual switch. It is basically an electrical switch which basically switches between two circuits. So let us discuss this first. Let me read this first. So internal circuit of a relay, one side of the circuit is a coil which when energized causes a terminal to switch from one which is normally closed circuit to another which is normally open circuit. Now let us see the circuit in front of you. You see that there is a coil kind of a thing here, and coil has two terminals. One is this terminal and one is this terminal. So when this coil is not energized, what happens is this kind of a this plate or an armature kind of a thing is actually in the connected to the NC terminal. So NC stands for normally connected, normally closed. So normally closed means now this coil is not energized. So because it is not energized, this is not attracted to it. So it is away from it and it is now connected to NC. So you can see that COM over here, which is the um, which is the common point, is now connected to the NC. So when there is no electricity in the coil, COM is connected to NC. When I connect the coil to an electric current, the coil gets energized. This armature will be attracted towards it, and when it is attracted towards it, it gets connected to NO. So so that means when this coil is energized, COM will then be connected to NO. So when this is not energized, COM is connected to NC. Alright. How many terminals do we have in all? We have 5 terminals in all. So we have one is T1 and T2, that is the two terminals of the coil. Okay. C is common, so this is common. And NC and NO are normally closed and normally open. Let us take a simple example. NC is connected to a blue LED and NO is connected to red LED. And this is connected to power, to 5 volts. If I do not give any current to the coil, which which LED do you think will be switched on? The blue LED which is connected to NC. We will first of all create that circuit for that also. Okay. And what happens if I give this coil some current? So when I give this some current, this gets switched to NO. So when I give this some current, it will actually go and connect to NO, and then red LED will get switched on. Okay. This is a simple example that I've given. All right. This is the internals of an LED. You can see that this is a coil and iron core that you see over here. This is the coil and this is an iron core over here. And you have an armature. You can see this is the hinged armature. The hinged armature is the common point, and there is a contact on above and there is a contact below. You can see that this is in the not energized position. So when it is not energized, this hinged armature is not attracted towards the coil and iron core. It is not attracted towards the coils and it is connected to the normally closed contact. You can see on top. And when you give this coil and iron core, you energize it, what will happen? This will get attracted. So when this gets attracted, it will be connected, it will disconnect from normally closed and it will connect to normally open. Okay, this is the internals of a relay. And you can see there is a spring which basically when this is not energized, the spring will pull it and it will go away from the armature and it will connect to normally closed again. All right, this is the internal circuit that we have just seen. This is the total circuit that they have actually shown. Again, 5 terminals. This is the relay on the left hand side. There are 2 terminals. This is the coil and the 2 terminals of the coil. And this is the armature, which is right now connected to NC. And when I energize this particular coil, this armature will get connected to NO. You can see here it is now connected to NO. You can see that I have given it current using this battery. So I have energized this coil. So when I energize this coil, this particular armature now disconnects from NC and connects to NO. And when it is connected to NO, you can see that this whole circuit gets closed and this the bulb will glow. Now you can see there is another power source here. There is one power source here. So that means there is one power source which is actually powering the coil, and the other circuit is another circuit. So we don't care what that other circuit is. That is what we are actually controlling from this one. So this is what is happening. So that means this is uh, energized, this is not energized, energized, not energized, energized, not energized. Okay. So where is it used? When we need switching between two power sources, for example, when switching to a backup power supply in the case of a main power outage, switching the motor's power supply to change its direction of rotation, or switch simple on off switching. So that means I want to switch a light circuit on or off. For example, if I want an Arduino to control an AC, for example, I want to switch on an AC or off an AC. How do I do that? Can do it using a relay. So that means the coil will be actually controlled by the Arduino, whereas the other part will be actually switched using Arduino, but that circuit is not part of the Arduino circuit. This is an actual relay. Normally in your kits you will get a relay like this. Okay, so after we have seen what a relay does and what are the internals of the relay, we can now go and work in Tinkercad and see what relays, how can we actually program a relay over there. All right, I have already brought in an SPDT here. Okay, so this is an uh, SPDT device, and it is normally of this size, but I have blown it up to show you what is the internal structure like. See the internal structure. You can see this diagram. When you see this diagram, you see that this is the coil, and you can see these are the 6 terminals that are there. And how do we connect these terminals? Now terminal 5 and terminal 8, these are the 2 terminals of the coil. All right, these are the 2 terminals of the coil. This one on this terminal 7 is the NC terminal. All right, that is normally closed terminal. This one is normally open terminal, and these are two common terminals. So these are both actually connected to each other. So what is actually going to happen now? If I do not pass energy from 5 to 6, that means I do not pass it any current. What is going to happen is that this particular terminal is going to be connected to this particular terminal. So that means 1 and 12 are actually connected internally, so there's no problem. So 1 and 12, they are actually connected to terminal 7. But when I energize terminal 5 and 8, what is going to happen is these two are going to be connected to terminal 6. All right. Let us now start working on TinkCAD. Let's see how things happen. Let us bring in an LED, a resistance, a battery. We'll bring in a smaller battery. All right. We can bring in a switch. Let's bring in this switch. So what are we going to have work on is we are going to give power to the coil. So coil is actually terminal 5 and 8. So let us now give power to terminal through a switch. Let me bring in the switch first. Switch here. Okay. So that means I'll connect this here. All right. And this to terminal 5 and this back to terminal to the negative of the battery. Let's color it black. So what is going to happen is when I switch this switch on, this battery will actually charge the coil, and the connection will change from terminal 7 to terminal 6. So how are we going to do that? Let's have another battery. So that means this is the battery for the output. Let's have it a two battery kind of a thing system. Okay, and let's connect the positive to the common. So I can connect to either terminal 1 or terminal 12. So both of them will work the same way. And let's make this positive. Now, do I want to switch it on, this LED on, when this actually will be connected? So when this is basically charged. So yes. So let's connect it properly, and that's it. So what is going to happen when I start the simulation? This switch is on. Okay, this switch is on. All right, it requires more. Yes. So this coil also requires a minimum amount of voltage, that is 3 volts. So the moment I changed it to 3 volts, it has now started working. So see what is happening now. When I switch this off, when I switch the relay off, see, I have actually connected this particular battery through a switch to the coil, and coil is terminal number 5 and 8. Terminal 5 and 8. So when I switch, see, right now it is actually connected to NC. So that means this particular terminal, let me change this a little bit. This particular terminal, uh, this one, sorry, this terminal is actually connected to this one, which is normally closed. Okay, so that means now what is happening? Okay, what is happening is when I switch this on, what happens is that this coil gets charged, and thus the relay switches from NC to NO. So that is to this one, and the red LED gets switched on. Let us experiment a little more. Let me bring another LED and another resistance. Okay, and let's connect them also similarly, and let me connect that to the NC part. What do you think is going to happen now? When the switch is switched on, when the switch is switched on, the coil gets energized and the red LED will be switched on. Let me change this to a yellow LED. Okay, let's see the simulation now. This is the switch is off. That means the coil is off. Now the connection is between 12 and 7. 12 and 7. And the electricity passes from 12 to 7 to yellow LED and through the resistance back to negative. But when I switch on this particular switch, what is going to happen is this coil gets charged, and when it gets charged, now 12 is now connected to 6, and the red LED gets switched on. So can you see what happened here? What have we done? We have basically connected uh, a relay with two LEDs, and we using a switch. This could have been a push button switch, right? Let me change this to a push button switch. Let me remove this. Let us have another push button switch. Okay, and I will connect the positive here and this. Let's see what is going to happen now. So right now, the because the push button has not been pushed, so yellow LED is on. But when I push this switch, the yellow gets switched off, the red one switched on. When I leave this, yellow is on. When I push it, red is on. When I leave this, yellow is on. Now you can see I have used a physical switch. I can use Arduino programming to do this. Let us do that in the next video. You needed to understand what a relay is, how does it work, and this is how it works. And we will do the rest in the next class. Thank you for watching this video, and we'll see you in the next one.